My name is Florence Alice Matingao, and I'm the founder and managing director for Agribusiness Solutions Limited. From 2016, we have been aggregating sorghum for East African Maltings Limited, which is used for brewing. And our 2,000 contracted farmers use conservation agricultural methods. Conservation agriculture is a sustainable approach method to improve agricultural production, which aims to protect soil from erosion and degradation, and then increase crop yields. Minimum soil disturbance, maintenance of permanent soil cover, and use of crop rotations are the three main principles of conservation agriculture. These principles are employed by our farmers. Our farmers also plant drought-resistant certified seeds. Gadam is a certified seed variety for the more arid areas like Eastern Province of Kenya. It is distributed by Kalro Katumani, that is a Kenya Agricultural, Livestock and Research Organization. Sila variety from Seedco does well in areas with more rainfall, like in western sides of Kenya. Karim Tamawan is a variety we plant in our irrigation sites. Our farmers also do crop rotation between sorghum and other crops like beans, which are legumes or green crumbs. They also plant trees like avocado and digging terraces. 3 months after planting, the sorghum is ready to harvest. Then it is dried, and after drying it is thrashed and winnowed to remove the dirt. Then it is weighed and brought in our aggregation centers. We pay the farmers and deliver it to the end user, that is East African Maltings Limited, and it is used for making beer. The Ministry of Agriculture supports our farmers through the Kenya Cereal Enhancement Program KSEP CRAL and links them to crop inputs. Crop insurance is provided by ECA Africa to mitigate adverse climatical conditions to the farmers. Our finance partner is Rafiki Microfinance Bank through the Finance Inclusion Climate Change Fund, which is a guarantee financing both for crop inputs, financing, and working capital. Training is done by UNFAO together with the EML staff, and they train the farmers on the best farming practices, management of aflatoxins, regenerative, and conservation agriculture. This project has been very lucrative, and 80% of our farmers are women, 15% are youth, and the other 5% consist of men and people living with disability. It has changed the livelihoods of our people, and you can see it looking at different indicators of wealth, like the type of housing they have. However, in 2019, the COVID-19 pandemic struck in the globe, and we were very, very adversely affected because the government of Kenya put restrictions on the sale of beer, which included beers made from sorghum. Our farmers practice mixed farming, where they also grow avocado. We earlier started processing avocado oil and decided to expand our operations into managing the waste. The waste peels make briquettes and biochar fertilizer. The waste seeds are either planted into seedlings to be given back to our farmers, or the broken ones make biodiesel. The waste avocado cake or the remaining pulp feed the black soldier flies, which after they are harvested, the waste is a fertilizer called frass. This is a circular economy model. These products reduce greenhouse gas emissions. Now let us look at carbon sequestration in this mixed farming between sorghum and avocado. Biological sequestration involves the net removal of carbon dioxide from the atmosphere by plants and microorganisms and is stored in vegetative biomass and in soils. The main natural carbon dioxide sinks are normally four. That is the soils, the grasslands, the peatlands, and forests. And forests store carbon dioxide either in the soil or in wood products or in regrowth or new forests, which is afforestation. So carbon sequestration has the potential to substantially mitigate global warming impacts. At the same time, employ methods to enhance carbon sequestration in soil will increase soil quality. Carbon is stored within soil organic matter. Soil organic matter is a complex mixture of carbon compounds consisting of decomposing plant and animal tissue, microbes like protozoa, nematodes, fungi, and bacteria, and carbon associated with soil minerals. Methods that significantly enhance carbon sequestration in soil include conservation tillage or no-till farming, cover cropping, and crop rotation. And these are the three techniques employed by our farmers in planting sorghum. So this is basically conservation agriculture which our farmers are being practicing. The other two things are grasslands and peatlands. And sorghum is a grass and it stores carbon in its complex root system. Final thing in biological sequestration are forests. Trees and plants in forests draw carbon dioxide out of the atmosphere when they are growing and release carbon dioxide as they decay. In general, forests store carbon like a bank account when they are in a stable state. And forests store carbon in four ways. The first one is in soils, which, as we've said earlier, is through either zero tillage, cover cropping, and crop rotation. The second way is through wood products, then regrowth and new forests, which is afforestation. Soils store the highest amount of carbon, and when they are cut, this carbon is released to the environment or during soil erosion. So in our project, we have come up with the innovation of briquettes to ensure that communities do not cut trees, either for burning charcoal or for making firewood. This way we ensure that carbon is not released by cutting trees, which leads to land degradation. The second way that forests store carbon is through wood products. Wood can be incorporated into construction material for houses, for furniture, or for other durable products. That sequestering forest carbon over years or even over centuries until that house is torn down and the wood is burned or sent to landfills. Paper products, however, may be disposed of quickly, like the flyers and the newspapers, and they decompose in landfills or may last a longer period, like in books. So in our innovation, we collect these waste papers, which we soak and we use as a eating agent in making briquettes. The other way the forests store carbon is through regrowth of harvested forests. Like when timber is cut, it takes time for those types of trees like eucalyptus to grow again. And this regrowth means that the harvested areas regenerate to become forests again. So there is substantial new storage of carbon occurring in the areas previously harvested. In our innovation, this occurs in the sorghum ratoons, and when the avocado trees are cut, they regrow again, so sequestering carbon. Forests store carbon through new forest or afforestation. And in our project, we are planting seedlings from the avocado seed waste. The whole seeds, which have not been broken in the distoner, are planted and later grafted with the Hass variety and given back to our farmers. Our project combats climate change because it addresses all the sinks which are used in carbon sequestration. Biological sequestration of carbon offers many potential advantages. The first one is that it could sequester relatively large volumes of carbon at comparatively low cost. Secondly, it's protecting or improving soils, water resources, habitat, and biodiversity. It can generate rural income and promotes more sustainable agriculture and forestry practices. And in this innovation we are going to be looking at promoting more sustainable agriculture and forestry practices. About 12,000 avocado farmers each has 2 acres of land, and each acre has almost 500 trees because most of them are the traditional varieties which were not planted with the right agronomical practices. So this means so far we have been able to rehabilitate 24,000 acres of land with about 12 million trees. Our goal is to mitigate the effects of climate change, which are manifested through floods, tsunamis, and land degradation, improve the livelihoods of our farmers, our women, and the youth, and continue to give them a sustainable source of income and achieve different sustainable development goals.